Good morning. In this session, I am going to explain you problems based on a relative velocity. So, here let us see what is relative velocity. Suppose V1 bar and V2 bar are velocities of two objects. Relative velocity of the first body with respect to the second body. V12 bar. This representation we use it for the relative velocity of the first body with respect to the second body. This is V1 bar minus V2 bar. Exactly in the same way, if I ask you what is the relative velocity of the second body with respect to the first body, what will be your answer? V21 bar. Relative velocity of the second body with respect to the first body. This is equal to V2 bar minus V1 bar. Then we have our parallelogram law of vectors to find the difference or to find the sum of two vectors. Now, this is the concept of relative velocity. Now, let us read the problem carefully. An aeroplane is flying with a velocity V1, that is V1 is equal to 800 kmph relative to air towards south. So, velocity of the aeroplane is given as 800 kmph south. South is taken as minus j bar, isn't it? See here, reference directions I am telling. This is east, this is west, this is north, this is south, and unit vector along eastwards is I bar, unit vector along westwards will become minus I bar. So, this is I bar minus I bar, this is j bar and this is minus j bar. So, here aeroplane is flying with a velocity V1 equal to 8 kmph towards south. A wind with a velocity V2 is blowing from west to east. So, here this is aeroplane is flying with a velocity, it is given as V1 800 relative to air. So, if we take velocity of air as 2, they have mentioned velocity of the aeroplane with respect to air is 800 kmph south, and velocity of wind is given as V2 is equal to 15 meter per second blowing from west to east. West to east means in this direction, so that is I bar. See here, this is given as 800 kmph. 800 kmph minus j bar, right? But velocity of wind is given in meter per second. First of all, both of them must be in the same units. So, look at the options, everything is given in meter per second. Let us convert that aeroplane velocity with respect to wind into meter per second. To convert kmph to meter per second, we have to multiply that with 5 by 18. So, here, so cancel 9 times, this is 400. So, this is 2000 by 9 meter per second j bar. See here, what is asked in the problem? What is the velocity of aeroplane with respect to earth? So, what is the actual velocity of the aeroplane? V1 bar is asked. So, what is the relation? V12 bar is equal to V1 bar minus V2 bar. You are asked to find out V1 bar. So, V1 bar is equal to V12 bar plus V2 bar, right? So, here let us see, just substitute the values. So, V12 bar is equal to this one minus 2000 by 9 j bar. V2 bar is 15 I bar. So, here actually in the options just magnitude is given. So, V1 is square root of 2000 by 9 whole square plus 15 square. So, we can just guess the answer approximately there. Look, this 9 if you take it approximately as 10, it gets cancelled 200 times. So, V1 is equal to square root of 40,000 plus 225. So, this is 40225. So, it is greater than 200. Exactly calculate, if you calculate that, it will be 221.7 meter per second. You can just find it out from the options. You can select the answer from the options because it is greater than 200. There is only one option with greater than 200. That is about magnitude. That is what asked in the problem. We are done. Actually, in the same question, direction can also be asked. So, here to find out the direction, concentrate on this, right. So, this is approximately, if you strike it here 100 times, it will be little more than 100, just approximately I am taking it as 100. X is positive, Y is negative, so it will be in this quadrant. Okay, so let us try to find out this angle. So, tan alpha is equal to opposite side, that is y coordinate 100 by adjacent side 15. So, it is 6 point something or 6.7. So, alpha is equal to tan inverse 6.7 south of east. So, this is the angle at which the aeroplane is flying, right. So, here I am explaining you that problem once again. Follow this problem carefully. An aeroplane is flying with a velocity 800 kmph relative to the wind. So, velocity of aeroplane with respect to wind is given as 800 kmph south, that is minus j. Wind velocity is given as 15 meter per second. So, we converted this into meter per second. So, you are asked to find out the velocity of the aeroplane with respect to the ground or with respect to the earth. That is nothing but absolute velocity of aeroplane V1 bar. So, relative velocity of 1 with respect to 2 is V1 2 bar is V1 bar minus V2 bar. Here V1 bar is the absolute velocity of the plane, that is what asked in the problem. So, V1 bar is V1 2 plus V2. So, just we have written that, and when once we have written this in the vector form, magnitude is root of ax square plus ay square. Direction is alpha is equal to tan inverse ay by ax. So, here as it is south, this is east. So, we mentioned this as tan inverse 6.7 south of east. So, we could find the magnitude and direction of absolute velocity of the aeroplane. That is our first problem. Now, coming to the second problem. A particle is moving eastwards with a velocity V1 is equal to 5 meter per second east. East is taken as I bar. Velocity changes to 5 meter per second north. V2 bar is given as 5j because north is taken as j. In time 10 seconds. So, what is the acceleration in this time? So, you are supposed to find the acceleration. We know acceleration is rate of change of velocity. Change of velocity is V2 bar minus V1 bar. So, acceleration is V2 bar minus V1 bar by t. So acceleration is v2 is 5j minus 5I divided by time is 10. So magnitude becomes root of 5 square plus 5 square, 5 root 2 by 10. So this gets cancelled. So root 2. So answer is 1 by root 2 meter per second square. Okay, direction. See here, this is north and minus I is west. So here actually if you draw that vector, this is east, this is west, this is north, this is south. I is negative and j is positive. It is like this. It is given this is 5, this is 5. So this angle is 45. So angle 45 means it is exactly between north and west. We say the direction is northwest. If a vector makes exactly 45 degrees with both north and west, we say it is in the northwest direction. We call that as northwest only when the angle made by the vector is 45 degrees with both north and west. Okay. So that is, the answer is this, 1 by root 2 meter per second square northwest. Okay. Now coming to this problem, look here. Wind is blowing from south to north. So wind velocity is given as 10. From south means towards north. So 10 j bar. But to a cyclist it appears to blow from east. So velocity of wind with respect to a cyclist is 10 I bar, because the wind actually blowing towards north but appears to blow towards east. It appears blowing from the east means towards west. So here this becomes minus I bar. Okay, what is the velocity of the cyclist? V2 is how much? So from the relative velocity concept, V12 bar is equal to V1 bar minus V2 bar. From that V2 bar is equal to V1 bar minus, if you take this to that side, this like this. So minus V12 bar. Substitute this here. V2 bar is equal to V1 bar, that is 10j, minus V12 bar, minus of minus becomes 10I. This is the cyclist velocity. So the magnitude is very obviously 10 root 2 meter per second. I is taken as eastward direction, j is taken as northward direction. So northeast. So it is 10 root 2 meters per second northeast. That is the answer. Okay. So towards northeast, look here, blowing from, so exactly towards northeast. That is the correct answer for that problem. Right. Now let us go to the next problem. Look here. A ship A streams down north, meaning towards north. So velocity of the first ship is 8 kmph northwards, j. And ship B due west, V2 bar is equal to minus 6I, because due west. Velocity of A with respect to B, we need to find out. V12 bar is how much? So here velocity of 1 with respect to 2 is V1 bar minus V2 bar. This is 8j minus of minus 6I. So if you find out the magnitude, it will be root of 8 square plus 6 square, 64 plus 36, 100 under root, it is 10. So the answer is 10 kmph. We just found the magnitude. if you look at the answer, there are directions also mentioned. So, I am writing relative velocity of the ship A with respect to B as 8j plus 6I. If you draw the diagram, this is east, this is west, this is north, this is south, both are positive, it is like this. So, here this is 6 and this is 8. So, here with respect to east, it is at an angle alpha is equal to tan inverse opposite side by adjacent side 8 by 6, that is 4 by 3, north of east. So, let us check whether that option is there or no. Magnitude is 10 kmph, tan inverse 4 by 3 north of east. So, the first option is true. Tan inverse 4 by 3 north of east with a magnitude 10 kmph. That is another problem. Look here. Next, we rain umbrella problem. This is also, as we know, an example for relative velocity. See here, I will tell you a separate method for that. Actually, in the books this is not given. I did not see anywhere this kind of notation, but while solving the problems, if we take this notation, we can solve that very easily. Okay? So, here look, just any horizontal direction is taken as I bar only while solving rain umbrella problems, and vertically downward direction is taken as J bar. So, I am telling you different method. We are just following totally our convention, right? So, horizontal direction is taken as I bar. Suppose if the person is moving horizontally eastwards, eastwards is taken as I bar. Suppose he walks horizontally northwards, north is taken as I bar. So, that horizontal direction given in the problem is taken as I bar, and vertically downward direction is always given as J bar only when we are doing problems based on rain umbrella. Then the problems become very easy. Look here. So, now suppose it is raining in the vertically downward direction and a man is walking along the horizontal with a velocity v. In which direction he should hold the umbrella? So, he should hold the umbrella in the direction of velocity of rain with respect to him. So, against that relative velocity, he has to hold the umbrella. Now, here from the concept, velocity of rain with respect to man, relative velocity of rain with respect to man is VR bar minus VM bar. So, VR bar plus minus VM bar, right? So, VRM is the resultant of VR and minus VM. VM is in this direction. Look, VR, if you take the vectors coming out of the origin, this represents VR. If this is VM, its negative vector minus VM will be in this direction. So, here see the resultant of these two from parallelogram law, this becomes VRM. So, for this man, rain appears to fall in this direction, he should hold the umbrella at this angle in order to protect himself from rain. So, actually for the man, rain appears to fall along this direction. So, that is just rain umbrella problem. Now, in this problem, let us see what is given. Raindrops are falling downwards vertically. So, I am just following this notation. Velocity of rain is 4 kmph downwards. For a person moving forward, see velocity of man, he is just moving forward with a velocity 3 kmph. Let us take it as 3J. Feels rain at, meaning, so what is the velocity of the rain felt by the man? Felt by the man is nothing but velocity of the rain with respect to the man. Vrm is equal to Vr bar minus Vm bar, that is 4J bar minus 3I bar. Magnitude is root of 4 square plus 3 square. It is 5 kmph. That part is very simple. So, just we could find out the magnitude effortlessly. Suppose in the same problem, if direction of rain velocity with respect to man, if you are asked to find out the direction of rain velocity with respect to man, how to find it out? Look here, from this Vrm is equal to minus 3I. So, here the person is moving forward, it is mentioned. Suppose if he mentions in the problem that the person is moving eastwards. So, this is I bar and this is J bar, 4J minus 3I. It is like this, right? X component is 3 and Y component is 4 here. Always we mention the direction of rain with respect to the vertical. So, this angle we need to find it out. So, if you take this as alpha, tan alpha is equal to 3 by 4, alpha is equal to tan inverse 3 by 4. If this is east, this becomes west. So, west of vertical. That is the direction of rain with respect to the man. So, if you are asked to find out the magnitude, it is very simple. If you are asked to find out the direction, we just follow this notation because that is just for convenience we have taken, nothing wrong in it. Okay? So, that is rain umbrella problem basic model. Go to the next problem. Look here. A man is travelling at 10.8 kmph. 10.8 kmph in a car on a rainy day. That is the velocity of man. He holds an umbrella at an angle 37 degrees with vertical, so that he is not wet. Raindrops fall vertically down. What is the rain velocity? See here, I am drawing the same diagram. This is the horizontal direction. This is the vertical direction. So, man is travelling along the horizontal like this, and it is raining in the vertically downward direction. Just now we have seen this becomes velocity of rain with respect to man, and this becomes the umbrella direction. He is holding the umbrella at an angle 37 degrees with the vertical. You see, I am just reading out the problem, observe the diagram. So, a man is travelling at 10.8 kmph in a topless car on a rainy day. He holds an umbrella at an angle 37 degrees with vertical, so that he doesn't wet. If the raindrops fall vertically, what is the velocity of the raindrop? Okay, so from this it is very clear, this becomes Vm tan 37 is equal to Vm by Vr. Tan 37 is 3 by 4. Vm is given as 10.8 kmph, but here options are mentioned in meters per second. So, better convert that into meter per second. 10.8 kmph is to be converted into meter per second. For that we multiply that with 5 by 18. This gets cancelled 0.6. So, it is 3 meter per second. 3 meter per second. So, velocity of man is 3 and velocity of rain you need to find it out. Very simple. Velocity of rain is 4 meter per second in the vertically downward direction. That is the answer. Right? Let us go to the next problem. When a man is standing, rain appears to fall, falling at an angle 60 degrees from the horizontal from his front side. So, a man is standing at this point, rain appears to fall at an angle 60 degrees. So, this is the actual velocity of the rain making an angle 60 degrees. That is what is given in the first statement. When a man is standing, raindrops appear to him falling at 60 degrees with the horizontal from his front side, like this. When he is travelling at 5 kmph, then rain appears to fall at 30 degrees, like this. This is given as 30 degrees. So, this is velocity of rain with respect to the man. In the first case, man is stationary. So, velocity of rain with respect to a stationary man is nothing but absolute velocity of the rain. That is making 60 degrees with the horizontal. But when the man started walking with some 5 kmph, rain appears to fall at 30 degrees. It is quite interesting. Look here. So, if this is Vm, this will be equal to minus Vm. So, Vrm bar is equal to Vr bar minus Vm bar. This is nothing but Vr bar plus minus Vm bar. So, velocity of rain with respect to man is the resultant of Vr and minus Vm. Look, in this example, what is the angle between Vr and minus Vm? Vr is like this, Vm is like this. Angle between Vr and minus Vm is 60 degrees. And if you observe, angle between Vrm and Vr is 30 degrees and angle between these two is also 30 degrees. In one word, we can say like this. See here, this is minus Vm, this is Vr and this angle is 60 degrees. Their resultant Vrm is exactly the angular bisector of those two. So, the resultant of two vectors is bisects exactly, or alpha is equal to theta by 2 only when the two vectors are of equal magnitude. Just by looking at the problem, as the angle made by the resultant is with both of them is exactly the same, both the vectors Vm and Vr have the same magnitude. So, in that question, velocity of man is given, and here we proved that velocity of rain is also equal to that of man. So, it is just 5 kmph. So, answer is again 5 kmph. The same kind of problem is given twice in JEE. Okay. So, here follow me very carefully. With respect to a stationary, another problem I am telling in JEE. With respect to a man standing, velocity of rain is 10 kmph and it is falling at an angle 60 degrees with the horizontal. When he is walking at 10 kmph, rain appears to fall at 30 degrees. What is the velocity of the rain? So, the original velocity of rain is 60 degrees. Velocity of rain with respect to a moving man is 30 degrees, exactly half. That is possible only when rain velocity and man velocity are equal. As man velocity is given as 10 kmph in that problem, velocity of rain also becomes 10 kmph. In this problem, velocity of man is given as 5 kmph, velocity of rain also becomes 5 kmph. Very interesting model. Now, next problem. See here, a person crossing a road with a certain velocity due north. So, the person is moving towards north, sees a car moving towards east. Relative velocity of the car with respect to person is root 2 times the velocity of the person, angle made by the relative velocity with east. Now, look here. To a person crossing the road with a certain velocity north. So, velocity of the person is V, north is taken as J bar, right. Sees a car moving towards east. So, car velocity is, we do not know, let us take it as V2, but it is moving east. And with respect to the person, relative velocity of the car with respect to the person is root 2 times the velocity of the person. That is what is given. Angle made by relative velocity with the east, that is what is asked. Now, look here, let me draw the diagram. This is east, north, west, south, I, minus I, j and minus j. So, the person is moving east with a velocity v bar, and velocity of the car is, this is V2. The car is moving with a velocity V2 eastwards, and the person is moving with a velocity due north. So, he is moving with a velocity V due north. So, velocity of the car with respect to the person is root 2 times his velocity, So, here just look here, this is given as V. V21 bar is equal to V2 bar minus V1 bar. From this, V2 bar is equal to V21 bar plus V1 bar. So, V21, that is the relative velocity. It is given as, see, from this, it is a root of, let us take this as, this one as P square plus Q square plus 2PQ cos theta. See here, you need to find out the, there is a small thing. Look here, I am just repeating this so that it will be easy for you. I am just repeating. Look, a person is walking with a velocity V towards north. A car is moving with unknown velocity, say V2 eastwards, but velocity of the car appears to be root 2 times the velocity. So, simply we can say these two are at right angles, J and I. So, actually V21 bar is equal to V2 bar minus V1 bar, that is V2I bar minus Vj bar, this is V21 bar. So, the magnitude of V21 from this expression is V21 is equal to root of V2 square plus V square, because angle between them is 90. So, from this expression it is given as root 2V. If you square that, 2V square is equal to V2 square plus V square. So, from this V2 is equal to 2V square minus V square, it is V. Okay, actually V2 square is V square, so V2 is equal to V. Both of them, they have the same magnitude V. If this is V, this is V, the relative velocity direction will be 45 degrees with both of them. So, here the angle made by the relative velocity with the east he asked, So, with both the directions, it makes an angle 45 degrees. So, the answer for that is 45 degrees. See here, actually, instead of doing all the things, you can straight away, just looking at the problem also, you can answer this. But follow me very carefully. See here, one is northwards, one is eastwards. The resultant of those two is root 2 times. This is possible when the magnitude of the resultant or magnitude of the difference of two vectors is root 2 times the magnitude of one of them only when they have the same magnitudes, if the angle between them is 90, because we have learned this, when two equal vectors are at an angle theta, resultant is equal to 2p cos theta by 2. Sum or difference is of two right angled vectors is root 2p. So, here he mentioned that the relative velocity is root 2 times the individual. So, definitely it will be the angular bisector. So, it makes 45 degrees. So, just looking at that problem also, you can answer, pick up the option there. Go to the next problem. A ship A steams down to north at 16 kmph and ship B due west at 12 kmph, relative velocity of B with respect to. So, here V1 is equal to 16 kmph north, north is J bar, V2 is 12 kmph west, west is minus I bar. Relative velocity of B with respect to A, V2 bar minus V1 bar, that is minus 12I minus 16J, the magnitude is root of 12 square plus 16 square, that is 20. 144 plus 256, it is 400 under root, it is 20 kmph. Suppose if direction is asked here, look, it is tan inverse 16 by 12, 16 by 12, minus j is south, minus I is west, south of west, or this is tan inverse 4 by 3, south of west. We know tan inverse 4 by 3 is 53 degrees, 53 degrees south of west. So, the answer is 20 kmph, 53 degrees south of west. That is the answer for that problem. So, now I will stop here. We have done some problems based on relative velocity. I will continue with some problems based on resultant velocity in the next session. Thank you and bye-bye.